Good morning, everyone. My name is Alex Brockett, and I am the transportation engineer for Portage Engineering. We're going to take you through some of our designs for this Ground Point Business Park project. So first, I'm going to take you through some general project information. So some changes to the project from what we were working on last semester. Josh, who is our project manager, is no longer working on transportation. He's now working on structural. And the entire group will not be going forward with those designs you saw from him last semester. So my transportation designs are still here, but those are going to be gone. And Josh is also now working on creating a gas station that will be put on a different parcel of the site. So we'll see that in a little bit here. A little bit of overview for the project. We can see the contour lines up here, as well as where some of the wetlands are. In the northwest site, kind of up in this area here, is where my road will connect, and that's where we're going to be looking at putting our parcel with the building and parking lot. The road is going to run kind of primarily east to west in through here, connecting over to Hub Court. And down here in the bottom right-hand side of the site is where Josh's parking lot is going to be, near the intersection of Indiana Avenue and Summit Street, so that it has a good amount of visibility. And later on, you'll see how we've divided this site into parcels for future development. So into some more transportation-specific stuff. First thing we'll take a look at here is the parking lot. So this underwent some pretty significant design changes after input from Professors Algebay, Reich, and Grossman last semester. We still have 146 spaces, which is over the requirement. We have our ADA accessible spaces, which you can see right in there. We included a loading zone right there. That's a dedicated loading zone. And this kind of small area you can see around the building is where there's going to be green area and some sidewalks. So then the next thing we'll take a look at is this is the created intersection. So I forgot to put my arrow on here, but north is up here. This is Indiana Avenue running right here. This is the road that I've designed running into it, and then this is Hub Court over here. And so this is the sample of that intersection. This will be an all-way stop. I kept the geometry of the intersection very similar, so that's why we have the same radii over here as we do between the existing intersection of Indiana and Hub Court. This is for Indiana and Summit. Again, north is up here. So Indiana is running here, the site's up in here, and this is Summit. Based on my analysis of this intersection, the only thing that needed to be added was one right-hand turn lane on the westbound traffic. So you can see that added in right there. We'll keep this as a signalized intersection, and that additional turn lane will improve the level of service to C following construction. We will be keeping the rest of the intersection the same, and I tried to keep as much of the existing geometry so that we're not disturbing buildings around there as is possible. This is our horizontal alignment here. We have two gentle curves that do not require any super elevation. This is designed for 25 miles an hour. So we have a minimum radius of 140 feet and a stopping sight distance of 155 feet. All of these were accounted for in making this alignment. The last thing I want to take a quick look at was the detour plan. Because we're only adding one right turn lane up here on the far side here, we're probably not going to have to close much of anything. That'll probably just be work that's going to be happening in the shoulder. But for any trucks that want to come northbound on Indiana Avenue, they might have to detour, so we brought them down here to, this is Millennium Drive down here. So for future work, I will be looking at creating some specific details for the cross-sections, such as the parking lot and roadway, as well as looking into making some specific details for handicap spaces, general parking lot spaces, and sidewalks for the site. With that, I will hand it over to Josh.
My name is Josh Drexler. I'm the project manager and structural engineer for Portage Engineering. And I've been tasked with designing a gas station for our site, which generally entails the 6,000 6,000 square foot building and a canopy to go over the top of 6 gas pumps. And these are some of the key design components that I've faced while doing this portion of the project. As for the building, I've been required to design for masonry walls and a steel system to support the roof and distribute the load to the walls. It's been required that the building has an open layout, so this means that there can't be any columns obstructing the space within the building. And the building is to be designed as a convenience store with a designated franchise space, and also have a flat roof for HVAC systems and other utilities, and also have parapets around the edges. As for the gas pump canopy, I've had to design for cantilevered beams and girders, and the client has asked me to put use steel columns encased in masonry. And these are some of my CAD drawings for the building. At the top is a top-down view showing the divided layout between the convenience store and the franchise space. The blue is parking spaces, the purple is the sidewalk, and the orange is overhead canopies. The franchise space will have its own drive-through. And so, as you can see in the back of the building, there is an overhead canopy that is going to be over top the window for the drive-through. And below here is a front view of the building. As you can see, the brick wall, blue is for windows, and the green is for the doorways. And the purple line is to show the roof line, and to show that it does include a parapet around the edge of the roof. It has been asked that each space has its own designated entrance, and that's why there are 2 entrances shown. And here's some of the CAD drawings for the gas pump canopy. The top is just as a reference for a reference to the building, and the bottom is showing more detailed measurements. And it can be noted that columns are placed at each intersection within the perimeter of the canopy. I then went on to create structural models using Riza Floor. I used a 992 material, a 25 PSF dead load that's accounting for the HVAC systems, a snow load of 50 PSF using the ASCE hazard tool, and a roof live load from the ASCE 7 roof usage that shows regarding the maintenance. And in this scenario, the snow load is the controlling factor. I used Volcraft metal decking for the roof spans, specifically the 1.5B-36 roof decks, grade 50 steel. And using the tables from Volcraft, I chose a 16 gauge deck at 7-foot spans for the building, and a 16 gauge deck at 6-foot spans for the gas pump canopy. And then using this information and data and running it through the program, along with my created models, Riza gave me steel shape recommendations for each of these members. I then had to check the results of Riza using my own hand calculations. And first, I had to calculate the ultimate distributed load using LRP equations. And then I could calculate the ultimate shear forces, the ultimate design moments, and bend moments of the members. And I then could use the steel construction manual to look up the acceptable limits for the steel shapes and compare them to my hand counts to see if they fell within the limits and work for my design. And the next step is to design the lateral system using Riza 3D. This will include walls, brace frames, and moment frames. I'll also be working on the connections designs. This would include tension braces, beam to girder connections, and beam girder to column connections. After that, I'll also be working on the design of column base plate and footings, as well as the foundation slab on grading. And with that, I'll pass it on to Chief.
Hello. My name is Jacob, and I am the Water Resources Engineer for Portage Engineering. I would quickly like to just review our scope a little bit. So I'm tasked with managing flood control for the entire future development, and then infiltrating or filtering 1 inch runoff from the building site, and that includes reducing the total metal load by 60% and the total solid load by 80%. And again, that is for the 40,000 square foot building and parking lot, not the new gas station that Josh is building. So a quick overview of the site. For water quality, I have permeable pavement and rain gardens. After recalculating a lot of the water quality volume and BMP sizes, I initially had a green roof as part of the design, but after recalculating water quality and removal efficiencies, I decided to omit the green roof after a conversation with Professor Weiss, just for that additional cost saving, and that water quality was already being handled by the rain gardens and the permeable pavement. For flood control, I have 2 dry detention ponds, one in the east end of the site and one on the north end of the site. And then I have a curb and gutter with inlets along the roadway and a pipe network connecting all of that for conveyance. Much of the design so far has been centered around the water quality best management practices. So for the porous pavement, the permeable pavement, porous asphalt on the parking stalls, I figured standard asphalt on the driving lanes, just as they're seeing more traffic, more cars moving through there, and then porous pavement on the parking stalls. This perforated under drain that you can see in this cross section will flow into the rain gardens. I decided to do that. One, there was just a lot of space constraints with our site being roughly 2 acres, and the building plus parking lot also being roughly 2 acres. So there wasn't a lot of space for pretreatment for those rain gardens. So this acts, one, as an overflow for that permeable pavement reservoir layer, and also as pretreatment for those rain gardens. These top pavement layers are subject to change as our transportation engineer finishes parking lot design, just verifying that the loads and everything check out with these pavement layers. Moving on to the rain garden. These rain gardens needed also to be redesigned just due to the parking lot size increase and the space constraints. I also decided to remove, I initially had planned for 6 rain gardens, and I went down to 4, but they are slightly larger than the initial 6. And then I have a 3-inch mulch base, and then an 18-inch engineered soil subbase. And that will include 50% sand, 30% topsoil, 30% compost. One, to help these plants grow, the soil is pretty clayey. It's not the greatest soil. And then 2, to help with that infiltration, as it's a CEE soil group, that sand and topsoil compost mixture will help infiltrate that soil better. It's a 3-to-1 side slope, which I forgot to put in the drawing, but the detail scale is sort of small. So, but that 3-to-1 was required by the State of Crown Point for side slope on that. Next steps include the curb and gutter design, along with inlets, the pipe sizing, confirming the dimensions of the detention basins, and that includes elliptical routing and choosing a design for the outflow device. And then finally, producing a complete cost estimate, itemizing all of the units and getting that cost estimate. So with that, I would like to pass it on to Samara.
Thank you, Jacob. I'm Samara Medina. I am the environmental engineer for Portage Engineering, and I'll be taking you through the Bradley wastewater collection system for this project. So just to go back to the beginning, I subdivided the parcel into 25 parcels, ranging between 0.5 to 3.5 acres. And then those parcels are split up into different land uses. One of them is commercial, the other one is like a 2-mix building that has commercial and residential, the gas station, and then some stormwater BMPs as well as the road right of way. So, and I also like attached which parcels are assigned to what. So this is an overview of it, of what it's split up to right now. I have junctions at manhole 2, which is up here, and then I also have another one at manhole 7 and then manhole 10 right here. And these are just the ones that are going to have other flow coming in from the lower half of the overall parcel. And then this is just an overview of my current, what I have for my wastewater generation. So I have it based off of what each parcel is going to be bringing into the pipe, as well as adding on the upstream flow as I go down the pipe. So overall, we're going to be having a flow of about 30,062 gallons per day, and then I also did total base flow, which took into consideration 40% inflow and infiltration. So this gravity collection system is following the rules of the 10 state standards as well as the Crown Point technical standards. So that's just minimum 8-inch PVC pipe, as well as maintaining a minimum slope of 0.40% for self-climbing velocity, and then also adhering to the cross connection. So just doing 1.22 meter to 4 feet cover to climb the pipe. And I'm just making sure that the crowns are matching at the junctions to make sure that there's no backflow, and then that there's a minimum drop across manholes of 0.05 meters. So with the pipe network, I'm going to be having 12 pipes, as well as, and for those, it's going to be with 13 manholes. It's going to be tying into the current infrastructure over by Indiana Avenue. And I'm just making sure that I start off with manhole 13, and everything above that is greater than 40% for the slopes, to make sure that it's following gravity. So this is my elevations currently. This is the upstream. I have ground where the manholes are going to be from the top, and then I'm going to just be dropping those, and that's why I have the inverts in there as well. This is what I have currently. However, this is going to be subject to change as I coordinate with our water resources engineer about where the rest of the pipes are going to need to be. So I just did manual check for each of these. I did based on the total base flow, and then I also did Q peak and then V full and Q full using CAM's chart, which is from the textbook. And then I just make sure that the velocity at Q peak is within 0.6 to 3 meters per second. So for these, for the most part, it does follow it. The up in the top, you'll notice that I have 0.3. Those are much more shallow in terms of the slopes, and I'm going to be probably dropping it down even more from where manhole 13 is, and then working my way back up to have a bigger slope at the top, because those have less wastewater being generated for those, and so that's why I have a much more shallow slope. And then I've been working on the vertical profiles for this collection system, but because I've been changing a lot of the elevations, that's been changing my vertical profiles. But for the most part, I've just been working upstream from the downstream control invert at manhole 13, which is where it's going to end up being the lift station. And then I just make sure that the flow is being added properly as it accumulated throughout the whole collection system at those junctions. So my next steps would be to finalize my collection system, more so just with the location of it. As Jacob mentioned earlier, we have certain spots for where the basins are going to be, and I just have to make sure that my lift station's about like 50 to 100 feet, aiming for 100 feet in terms of distance away from that, just to make sure there's no like cross contamination. So once I do that, I'll be switching where my lift station is. And then once I decide on where that location is going to be, I'm going to just perform pump selection and then cycle time analysis and then complete the cost estimate for the overall system. So that concludes our presentation. So now we are open for any questions that the audience may have. Yes?
Can you go back to that table where you show the velocity at, this one? Yeah, so I see that you put OK in front of the 3. So what's the minimum flow velocity under normal conditions, not peak flow conditions?
The lower half is, it's supposed to be 0.6. But I did, at the time that I had my Civil 3, when I was putting it on the rules, I put it as 0.3, and so that's why I okayed it when I did this chart.
So it's not okay
So it's
to have like 1 foot of in this case, like per second of velocity. And that's at peak flow. So imagine under normal conditions, your pipes can fill up with cements.
Right, yeah.
So that's so.
Yeah, that's something I take into consideration moving forward when I change that slope.
Okay. Is there a drawing to show where is the location of the lift station and the force main?
Yeah, I originally had my, going back to this overall one, I originally had my lift station at this location, but we are gonna have BMPs right here, and I'm supposed to be having that distance of 100 feet between a lift station and a BMP or any like stormwater. So I might end up moving it back up front where I had this location originally, because this one I would be having a distance of like 37 feet, which is not ideal. So I will probably be moving this and then taking out this pipe and moving it over here, and potentially connecting to this junction.
Actually, the other way is better because you want to keep your like wastewater away from the wetlands on the north. But it's fine to have a lift station next to like BMPs. There is nothing wrong about that as long as there is some sort of separation between them. And that's a big parcel, right? So
Yeah.
they're like a 3.5 acres or so.
Yeah, I think I was just focusing too much on this, like, the BMP that's gonna be here is really close to the edge, which is very close to my lift station.
And the force main goes from where to where?
The force main I have it currently going, it's not in this image, but it's gonna be going down and tying into this one right here. Because I was considering taking it up front to this one, but it would be too long of a distance, and this one just has a bit like, it's like a 4 feet, like up from there.
One question for Josh. Josh, did you consider the wind lift on the canopy in your design? Because it's an open canopy, and that's maybe the biggest concern rather than the gravity load on the canopy.
I hadn't taken that into consideration.
It's going to be flying away, yes?
Yeah.
Except if you have very strong footings in the ground to hold it.
Right. I'll have to look into that for sure.
So Zimar, I noticed your units were in meters,
Yes.
but I think the rest of your group is using English system, right?
Yes, that is correct. I originally, when I first started with my Civil 3D design, I went into metric and out of Euro. And so when I did switch my whole design over to English units, it didn't translate well, and so I've just been slowly adjusting. So I think I have it on here, one of my tables. I think I have Q peak.
There's gallons.
Okay, I didn't include this one, but I do have another table that has all of it transferred to feet.
Okay.
I converted to that. So I'll probably update that moving
Okay.
forward,
Yeah.
just to be consistent with the rest of it.
Yeah. And then I had one other question for you. You said that you had crowns matching at junctions,
Mhm.
so there's no backflow. What could you explain that? Because I didn't understand what you meant.
Yeah, so at the junction, we have several pipes coming into it,
Yeah.
and some of them are at,
Oh, okay, I got you.
yeah, so they're just like making sure that they don't, like, they match up. Although this one's a little bit higher than this one,
Yeah,
so that they don't
yeah, okay,
get overflow.
okay, thanks. And then Jacob, so the rain garden, you said it so quickly, I didn't get what percent compost is in the engineered soil that you're using?
I have 30% compost, 50%
Oh,
sand.
okay, there it is,
50%
yeah.
topsoil, 30% compost.
Is that, where did that ratio come from?
I got it from Purdue. I forget the exact title of the publication, but
Okay.
yeah.
Okay, so you're tasked with removing metals, right? So the compost would be really good at helping with that, but it's probably going to release a bunch of phosphorus and nitrogen.
Probably.
So you can justify that given your scope, but just so you're aware of that. And because most designs now are a lot less percent compost, like even 10% or something, because of
I'll have
the
to look at the
nutrient.
data on that location.
Yeah, okay,
I didn't look at the dates.
okay. And then,
But before you leave that, 50 plus 30 plus 30.
oh, yeah, yeah,
Oh, sorry. No, I meant to put 25 cents, I'm sorry.
okay. 20, yeah, there you go. And then on your permeable pavement cross-section, is the drain tile really gonna be touching the gravel filter course at the top? I don't know if that's,
Probably not. It's just how I drew it in there.
Okay.
So.
and so
there'll be a
where,
little bit of separation.
did you make this, or is that a standard?
No, I made that.
Okay,
Yeah.
and so where did you get the, like the gravel filter course and 3 inches of asphalt and,
So these were just assumptions from, I believe it was the Indiana Design Manual. But then, like I said, it is subject to change as I work with Alex on that pavement thickness, making sure that the roads match up
yeah, because,
for what the scope is.
okay, because there's 2 parts of permeable pavement. One is like just the water part, and the other is a structural part.
Right.
And I mean, it was a long time ago when I was like designing roads and stuff in the residential streets, and it was, I think the minimum was 4 inches of regular conventional asphalt.
Okay.
And so 3 inches of porous asphalt is going to be a lot weaker.
Right.
So you might want to look into that. And the geotextile layer at the bottom also. A lot of people are not doing that because it collects fines and clogs.
Okay.
So if it's required, I guess, you do it because Crown Point or the state is requiring it, but some things to think about.
Okay, thank you.
Mhm.
So one question for Josh, and I may be dating myself. What is A992?
It's just a type of material, type of steel material.
What are the properties? Is it like really strong? Is it, I don't know what it is. Like 836, 8572, I don't know.
And those are going up like the 2 probably most common use, like 836 and 8992, and like, what's it called, FY being the like 50 KSI.
Is that what it is?
Yeah.
Just to know the number there.
So just a couple of questions. On the transportation side, in the one intersection, you have 12-foot lanes coming down, and I think 11 on the side. Is there a reason for that?
That was just when I looked at it and took measurements online with our parcel viewer. That's what I found, was that it was, I believe it was Summit had 12-foot lanes and Indiana had 11-foot, if I'm not mistaken.
Is there like any concern about that, or does that all meet requirements?
It should all meet requirements. The lanes in my proposed road are 11 feet, so as long as the speed limit's low enough, 11-foot lanes are completely fine.
So the minimum would be 11,
Yeah.
12? Okay, thanks. And then on the water resources side, on the parking lot, you have the rain gardens in the corners.
Yeah.
So the parking lot, how is it graded? Or how?
Yeah, so I talked with Alex about that, and we talked about having it graded so that it all flows sort of from the center out to these corners, so that it all will be captured in those rain gardens.
Okay. And you're basically collecting runoff from the parking lot right into the rain garden. So a couple of things, does that change like how effective it is? Because you're really capturing debris and oil and things like that. And also, how do you maintain a rain garden? What would they need to do to maintain them?
Well, so, I am planning on having these, this overflow drain flow into these rain gardens. So in an ideal scenario, you have water infiltrate into the porous asphalt, and then as it fills up, it'll flow into these rain gardens. So this will actually act as a sort of pre-treatment for those rain gardens. And in terms of maintenance, there's cleaning that has to happen. Sometimes like it can get clogged, and so they'll have to go in and clean out some of that soil subbase, the mulch, and then replanting every now and again. I don't know how long the time span that is off the top of my head, but yeah, there's some maintenance associated with that.
Depends on how good your pre-treatment is.
Yeah.
Is there any overland flow going into the rain garden? Because you probably would want.
So there will be, like a little inlet here with some stone riprap. But ideally, with that 1 inch of rainfall, it infiltrates down and flows into here. But then in certain larger storm scenarios, it will probably overflow at some points.
Can I add that? So the large storm is rare and probably not, doesn't need pre-treatment because that's not going to really get treated much fraction of it anyway. But if there's the smaller storms that are flowing into that, like Professor Wright mentioned, you probably want some pre-treatment
Right.
there, or else it's going to be clogging.
Right. So I'm planning on having a sort of like riprap from those inlets. I mean, the detail scale is just small over here, so you can't really see it, but inlets here with riprap between the parking lot and the rain gardens. So one will help with stabilization of that slope, and then also with pre-treatment for those contaminants.
May I make a general comment? Okay. Can you guys, this is for all, capture the images in the layout, not in the model for like civil. It's hard for me, as an old man maybe, to read like in a black background in here. Those many of these are like figures or images. It would be more of the standard engineering drawings if they are from the layout rather than from the model with the white background in there. So maybe we can, yep, something like this. I can't read the black ones. Okay. No, that's true. That's the standard, more or less, like presentation drawings.
Do you have more questions here?
Oh, no, I'm sorry. Thank you.
So since we're on general comments, just for like the whole class, for images, I wrote a lot of comments like, provide a legend, label things, right? So like the little green squares on that, like, you may have said it, but like, I might be writing something and I look up and then I'm looking like, what is the little green square? What's a red line?
Right.
So just better communication in general for.
And the scale.
And the scale, yeah. Okay, anybody else? Okay, thanks.